Hey everyone, my name is Trevor Spires, and you are watching the first in a multi-part series covering VMware's TKG, so that's Tanzu Kubernetes Grid, the integration of that with VMware's Avi network solution. So that's VMware's enterprise advanced load balancing platform. If you weren't already aware, recently VMware made Avi the default ingress and load balancing operator for all TKGm deployments. And that comes with some really distinct benefits for VMware customers. One, that means if you own TKGm or you buy the TKGm license from VMware, you're going to get a basic version of Avi to use as the load balancing and ingress for free with that TKG license. Two, they've massively simplified and streamlined the deployment process of TKG with that AKO or Avi's Kubernetes operator integration. It's now really, really simple to deploy and something that you can have up and running really, really quickly. And number three, what this means is that you're really bringing all of the rich value of the Avi Networks load balancing solution into your Kubernetes clusters, okay? So that means all of the features of Avi, of course, load balancing, global site load balancing, WAF, etc., are now exposed and can be exposed to your Kubernetes cluster. And on top of that, you can still take advantage of Avi's rich analytics and logging capabilities to pull that into your monitoring or even just your daily operations of Kubernetes directly through the Avi analytics dashboard. I'm really excited about this one. I learned a lot during the installation process. My goal here is really just to share with you what I've learned. This took me a couple of weeks to get down. I'm hoping that by watching these videos, you can get up to speed much faster than I was able to. If this video helps you, please subscribe, or if you think somebody else could benefit from the series, share it with them. Send them the video. Maybe this can help them get their own deployment off the ground. All right, time to get started. Hey everybody. Today, we're going to take a look at the brand new TKG and AKO integration. I'm going to give you an overview of the AKO TKG integration and installation process. I'm going to try to boil it down to the simplest terms possible so that you could get this up running in your environment, whether it's for a proof of concept, whether it's for an evaluation, or hey, maybe you even are planning for a production rollout of some kind of Kubernetes management system like TKG. My goal is for this to be a kind of one-stop shop series that can help you get that initiative off the ground. Just a little disclaimer up front. I want to let you guys know this is recorded in early 2021, really right after version 1.3 of TKG and AKO came out. So I just want to mention that in the video because this is going to be constantly changing and evolving. I also want to say, I've been learning a lot just kind of through brute force playing around with this technology. I'm certainly not the end-all be-all expert on this topic. And I say that to say, I'd like to learn from you too. If you see something in the video series where you think, hey, maybe we could double click and dig deeper into that, or if there's, you just have some feedback for something that you think could be improved, or even something that you think might be interesting for other people to learn about, let me know. I'd really, really love to collaborate. A big reason why I decided to do this is because Avi, AKO, is now the default ingress for TKG, and really eventually for the entire Tanzu portfolio is my estimation, right? I know that because I was reading the documentation, okay? And so here are some links to documentation that are going to be really, really critical to your success in rolling this out. I'm hoping the video series will help you get this up and running in a pinch if you need to move quickly. But hey, if this is an environment that you're going to care for and love long term, please read these documents. They are really invaluable. And without these documents, there's absolutely no way that I would have been able to create this video. It's always a good idea to just ensure everybody's on the same page for what the Tanzu or Kubernetes implementation that we're talking about is. So I'm going to give you a quick walkthrough and overview of what's now called TKGm or TKG multi-cloud. And that's what I stood up in my environment. That's what the installation video will be a walkthrough for. And so that's what I'm going to walk you through right now. Okay. So TKG is really a Kubernetes management platform, right? And the architecture is really not that complex. If you already have an understanding of Kubernetes, you might find this to be pretty intuitive, actually, okay? The way it works is there's a couple of tools that an engineer or an admin would use. Okay, there's a tool called Tanzu CLI. You would download that from VMware's website, and there's also kubectl that they might use as well. The Tanzu CLI, you install it on a local box, right, or even on like a Bastion host or something, and you use that to provision what's called a management cluster. The management cluster exists for two primary reasons. Okay, number one is this is kind of the hub or the bootstrap environment that you're going to use to provision additional Kubernetes clusters. But also the management cluster can be used to do things like storing centralized services. So you might want to run, if you have a logging software, maybe you have some sort of monitoring or authentication service, you may consider running that inside of your management cluster inside of TKG, okay? You don't have to. You could deploy a separate cluster for that, but the idea of the management cluster is that you spin it up and it sits there, and it's going to be changing probably less than your workload clusters, which we'll talk about here in a second. So this can sometimes be the ideal place to put those central services that you always need to have up. So from the management cluster, once you have that stood up in your environment, then the world is your oyster, okay? All the hard work is done at that point, because once you use the Tanzu CLI to build your management cluster, that Tanzu CLI tool you can use and reuse to provision additional clusters in your environment. So with a single command, you can build an entirely new Kubernetes cluster for maybe a customer or some kind of internal stakeholder or an application team, right? One command, you can build that cluster out, and another command, you can scale that cluster out and add additional nodes to ensure that that cluster can host additional applications and maybe take more traffic, right? So the whole idea is that Kubernetes, right, can be pretty complex and time-consuming to manage all by yourself. So this is really a value-add implementation of building, managing those Kubernetes clusters, right? And what's great is with this architecture, you can build out a cluster like this one, where maybe it's just a dev cluster, and we're just kind of starting to play around with it. But maybe once that application that's built on that dev cluster is ready to go live, maybe you want to build out a more robust or a more scalable cluster. Well, hey, with one other command using that Tanzu CLI, all you would do is type a very similar command, and boom, you could have another cluster for your production environment. Now, I'm using dev and prod only as examples. You could slice these clusters up in so many different ways. It could be dev, it could be prod, it could be different lines of business within your organization. Maybe you're even servicing external customers and you're provisioning these for your customers. There's so many different ways you could leverage this concept, but this is the fundamental architecture. All right, you build your management cluster using the Tanzu CLI, and then also using the Tanzu CLI, you build out additional clusters. All right, and then once the cluster's there, it's just a Kubernetes cluster, right? We have some integrations with other VMware products like Avi, which I'll show you here in just a second. But from the perspective of a developer or somebody in ops, it's just Kubernetes. So they access that cluster with kubectl just like they would any other Kubernetes cluster, and the experience is all the same to them. That's a high-level overview of what TKGm is. What is Ingress? Where does Avi play into TKG? Why is this important? Why are we even talking about it? Well, here's the thing. By default in Kubernetes, when you provision an application, right, you're going to provision that in what we call various pods, right? And just for a sake of example, let's say I have a pod, and in that pod I have 3 replicas, okay? So you can kind of see my 3 pods here that are replicas. Well, you define replicas in Kubernetes within a certain deployment to basically add resiliency and scale to your application. So let's say this is like a web server. I could say maybe I want 3, maybe I want 100 different web server pods, and I just change a single number and it can scale that up and down, right? Well, that auto scaling is all really cool and fine and dandy, but here's the thing. What about end users, right? End users, they just want to open up their browser to access a piece of software and type in a URL. They don't really care about the pods, the servers on the back end doing all the stuff. They just need a unified experience, right? So we need some way to get user traffic into the cluster, and we need to do it in a way so that way we can spread user traffic across our various pods. That is where ingress and load balancing in Kubernetes comes into play. all right? And that's where AKO comes into play for TKG. Now, Kubernetes is really an orchestration and automation platform, right? It orchestrates and automates a lot of different stuff, but specifically when we talk about load balancing, what we're automating is the provisioning of your VIP, so your load balancer and your pool members, right? So that's that north to south ingress egress to your cluster, right? We do L7 services, so that's SSL, WAF, maybe content switching redirects, anything L7 and HTTP type of stuff that you need to do with your application. That's all automated by the native Kubernetes services, right? And then we also will automate the provisioning of DNS records, right? A user's not going to access an IP. We need an actual FQDN so they can hit that, right? So all this stuff is automated for you by Kubernetes, but Kubernetes, it still has to automate something, right? Kubernetes is not a load balancer, right? It is an automation platform. You have to plug a load balancer into it to make it work. That is where the AKO system comes into play. By setting up an Avi deployment and putting it outside your cluster, so you have your cluster here that's probably running on a series of VMs, either in the cloud or on-prem, and then you have your application or ingress service that's deployed. We're able to get that traffic in and out of your system very simply by leveraging the integration into Tanzu. All right, I keep saying AKO. It stands for Avi's Kubernetes Operator. Okay, Kubernetes, by the way, an operator is a really common way for you to plug external systems into your Kubernetes environment. And that's really what it does. The Avi Kubernetes operator, it runs in Kubernetes, and its sole purpose is to listen to Kubernetes. So it listens and it finds out when you provision a load balancer or when you provision like an ingress object. And as soon as it sees that, it's going to run all the necessary API commands to provision that for you and build that into your application, into your infrastructure, right? So specifically how this works is you're going to, in TKG, this is all deployed for you automatically, right? You can also use a Helm chart and other such things. This will all be automated, the deployment of this in TKG. So when you deploy, let's say, a workload cluster, what's going to happen is an AKO pod is deployed, and it's going to be manipulating your Avi controller. Okay, you're going to pre-deploy the Avi controller. That's one action you have to do. You have to deploy the Avi controller OVA, so that way you can tell AKO what to talk to. Okay, and so that's really it. There are some prerequisites that I'll walk you through in the next video of how to install that and how to prep your network. But once you have the operator in place, once your controller is in place and everything is configured, it kind of just works, right? Your users will keep interacting with Kubernetes just as they would traditionally, but now whenever they specify ingress configuration or they specify load balancing configuration, AKO is going to automate the deployment of that, and that means they're going to automate the creation of the VIP, the FQDN, so that way users can start accessing your application. All right. I want to make it clear, this is not limited to just provisioning VIPs. All right. Basically, anything you can do in Avi is now at your disposal within Kubernetes because of this integration. So think about, for example, WAF, right? They're maybe not in this exact system, but we also have ways to integrate GSLB or multi-site load balancing, global site load balancing, right? There's a lot of really rich, awesome features that you can pull in by leveraging this. Oh yeah, by the way, did I forget to mention analytics? If you've never seen Avi's analytics, you got to check it out. That is at your disposal as well for your Kubernetes application by leveraging the AKO operator to take care of your load balancing and ingress into your Kubernetes cluster. Stop. It's demo time. All right, I'm going to take you over to my environment, and I'm just going to show you how I can spin up an application leveraging AKO, and then I'm going to show you what the application looks like, and then in the next video, I'm going to dig deep into how you would get this running in your environment. All right? You are now looking at my demo environment. Just to quickly walk you through what I've got a TKG deployment. That means I've got a TKG management cluster. You can see here with my two TKG management VMs. And I've also got a workload cluster. My workload cluster is called TKG test. Okay, these are all hosted in vSphere. I've also got an Avi controller, and right now there's really nothing configured. It's just kind of sitting here listening, and you can see TKG-test. It's actually listening for stuff to be configured from my TKG-test cluster, okay? So what I'm going to do now is go ahead and pull up my VM. I'm just going to run one command to show you. If I run Tanzu, and remember, Tanzu is a command line tool that you use to provision, interact with clusters in TKG. So I just run Tanzu cluster get TKG test, the name of my cluster, and you can see I've got a cluster running Kubernetes version 19. All right, and I can look at some details here. I can also, I'm logged into that cluster with kubectl. Okay, so I can run kubectl commands and start manipulating that cluster. So I'm actually in a directory that's got a YAML file with an application that I'm going to provision it in there. So I'm going to show you the application real quick before I provision it so you can see what it does with Avi. All right. All right, so I'm in my file, that YAML file for this application I'm about to provision. I'm just going to walk you through what's in the file. All right. So first of all, I got it kind of split into 5 different chunks. First, I've got service 1, and then I've got another one, service 2. Okay, these are just services that my Ingress configuration is referencing. I just wanted to show you these because it's part of the provisioning process. All right. Then I've got really the most important part here. This is my Ingress configuration. All right. So in my Ingress configuration, you can see a few things. So first of all, you can see I've referenced here specifically to use Avi as my ingress. All right. So you would want to do this in your file, unless of course you have Avi set as the default ingress, which I don't. But yeah, this is an ingress configured specifically to load balance between some pods and to do basically URI direction based on the path. So I've got one path that's /old. This is going to route me to an old web server, and then I've got my default path. You can see the path is just basically anything, and that's going to take me to my my more recent web server. All right, and then at the very bottom, the last couple things I have, these are just the deployments of my web server, which I'm routing us to with that ingress. So that's the old deployment and the new deployment. All right. So that's it. I walked you through the config file. Now I'm just going to go ahead and provision that application so you can see what actually happens behind the scenes. So right now, Kubernetes is provisioning my pods and all of my various services as specified in that file. You can see right here, here are those backend pods that I'm running, and one is running an older version of my web server, and one is running a more recent version of my web server. All right, so this is going to take just a second to provision, and then I'm going to walk you through what it created behind the scenes in Avi. All right, let me see if everything is provisioned now. Look at that. All my pods are up and running. So now I'm going to show you in the Avi controller what that ingress and the various configurations I just showed you actually relate to inside of the Avi controller. All right, so now I'm looking at my application dashboard, and you can see I've got my test application that's been deployed, and you can see I'm load balancing to 2 different back-end pools here. Right? So these were automatically created based on those URIs and those deployments that I specified for my main file path, and then also for my /old file path. Okay. So Avi creates the virtual service, so the VIP, right? Avi also will create the FQDN if you have it set up to do so, and it will do things. For example, you can specify the certificate that you would like it to use if you're using SSL, right? I'm not in this environment, but absolutely you should do that if this is a production application, okay? And finally, in addition to provisioning the VIPs, is going to tie those VIPs to some backend services, okay? So if I go into my VIP, you can actually see, I go under the policies, and I go to data scripts, you can see that I have this TKG test data script, and it's listening for and keeping track of the URIs that are coming in as I'm requesting access to this application, so that we can do those redirects to the /old or whatever path that is being specified whenever I navigate to my application. All right, so I'm taking us back to the main view. By the way, the health checks are still running, which is why it's showing bad health. Ideally, this would be all green in your environment. If I waited for a while, all my stuff would turn green, okay? So let me show you. I've showed you the obvi configuration, right? But exactly what's happening behind the scenes. Well, now if I hit my VIP address, so I'll click refresh a few times here. If I click my VIP address, you can see I've got my application. I've got that Nginx app, and this is running that latest version, right? So this is my main URL, and I'm just hitting an Nginx 1.19 server, right? So what if I specify that /old URL that I was telling you guys about, right? So as I specify that, I'm going to smash refresh a few times. You can see I've got this older version of Nginx. So this is hitting a different pod based on that Ingress configuration that I put in place for that /old URI, okay? By the way, ignore the fact that this is a 404 error. I didn't edit the Nginx configuration, so it's not listening on this URI path. But this was purely to show you that I could route to different pods by showing you the different versions of Nginx. But generally, if this was an application, you would have the application listening to serve up some kind of traffic from this URI. And finally, just to clean up my lab, I'll go ahead and deprovision that application to show you that not only can you provision an application with this sort of system, but you can deprovision it. And this is why this stuff is so powerful, everybody. Now all I need to do is go in and run delete on that same application. And what's happened? Now all of these services that are associated with the application are being spun down. If I go back to my Avi controller, I'll click refresh. We should see all of those back-end pool members. Where'd they go? They're gone, right? And those will be reprovisioned, deprovisioned every time an application is spun up and down. That's my demo. Hopefully that made it clear. If you want to figure out how to get to this point, just check out my next video, and I'm going to walk you through the end-to-end installation for getting a demo like this up and running in your environment. All right, everybody, thank you again for watching the video. I hope that this was useful. If you have any questions, please feel welcome to reach out to me directly. I'm happy to help however I can. Keep an eye out for the next videos in the series if you want to learn a little bit more about this integration and getting it stood up in your environment. Until then, happy microservices, happy AKO, and happy automation. All right, everybody. I'll see you soon. Bye. Now it's time to cheat. Edit this part out, Bubba. Turn off health checks because you're a cheater. Cheater, cheater, pumpkin eater.